So today we are moving on in our understanding of how we classify and organize communities and populations. And the way we are going to do that today is by talking about ecological succession or ecological succession, however you'd prefer to pronounce it. It does not matter. So, my goal for today is to be able to describe what succession is and identify the type of succession a community is going through based off of certain observations or characteristics. Make sure that's not locked. So there are two types of ecological succession. Say that 10 times fast. And we're going to talk about them. So, welcome. First things first, what in the world is ecological succession? How many times am I going to say ecological succession a lot today? Too many. So, it is a series of more or less predictable changes that can occur in a community over time. Technically, all ecosystems change over time, but this is especially after disturbances. So, when a major disturbance takes over part of a community, um, some species will die out, other species will move in, and that whole thing will change over time. And that process is what we're talking about today. So, predictable changes on how a community will recover after a disturbance. Questions so far about this or about any of the activities we have done so far this week? It feels later in the week than a Tuesday. I think that's just because we all want fall break as soon as possible. So that is ecological succession. More or less predictable changes that occur in an ecosystem over time. There are two big types of ecological succession. And the difference between them is the intensity of the disturbance. So there's primary succession and there is secondary succession. And the big difference between those, is how bad the disturbance that kicked off this process affected that community. So, primary succession, secondary succession, both pretty easily named, but it all depends on the disturbance. Also, throughout this, sometimes I will say community, sometimes I will say ecosystem. If we remember from how we classify our kind of levels of organization in environmental science, a community is all of the populations in an area, and an ecosystem is is the community plus the physical surroundings. So sometimes we're going to be talking about just the physical or like we're going to talk about the physical surroundings, like the actual abiotic factors, and when that is the case, we will say ecosystem. And sometimes we are just going to be focused on the living things in that ecosystem, and that is when we will say community. So just a heads up with the vocab terms there. All right. So, two types of succession. The first is primary succession. Primary succession is what happens when we are starting with nothing. Absolutely nothing. It begins when we have no remnants of older communities. Everything is completely 100% wiped out, is what I'm most looking for. And only like pure rock is left behind. Primary succession does not happen as often as secondary succession because, in order for primary succession to take place, some pretty bad stuff has to go down. So, this is stuff like volcanic eruptions and glacial retreat. So, as glaciers move through an ecosystem, right, as a glacier retreats, it'll leave literally nothing but rock behind. And the same thing with a volcanic eruption. So when these things destroy a community, when that community or ecosystem not wants, but as naturally that community or ecosystem pushes towards what it once was before this big disturbance, we call that primary succession. We are going from pure, just blank slate rock to a thriving, diverse community. And that process is called primary succession. And there are some really important key players in the process of primary succession. So, this right here is a diagram of primary succession. As we see, we start with our bare rock, and then we move into our pioneer species, and I'll talk about what a pioneer species is in just a moment. We start breaking down, we start getting a little bit of dirt as that dirt forms. We've got small plants lead to big plants lead to even bigger plants, and then we've got this big community. This is why it is called succession, right? When we talk about like things moving in succession, or somebody's uh, who, what's the word I'm looking for? Like predecessor is that has that cess in it, that cess like base in it. So when we talk about succession, we're talking about this happens, and then after that happens, the next thing happens, and after that happens, the next thing happens. So we start with bare rock, and then we get the lichens, and the lichens make it possible for our small plants. But we can't jump straight from lichens to our big community. We have to go step by step by step by step in succession. So, we talk about pioneer species, and I mentioned lichens. A pioneer species is the first species to exist, or the first species, not exist, but like to colonize a barren area. So it is the first thing that kind of moves on to that bare rock. And lichen is a very common example of a pioneer species. It is not the only pioneer species. There are a lot of pioneer species, but lichen is a pretty common one. And I've got a little picture of it right there growing on rock. Now, lichen isn't just itself an organism. Lichen is actually what we refer to as a symbiotic relationship. We talked about symbiotic relationships. It is actually fungi and algae that grow together. So they are kind of inseparable, and they will work together. And as those fungi and algae work together, they will start to chip away at that top layer of rock. And as they chip away at that top layer of rock and they live their lives, they'll fix nitrogen and they'll die. Because that's the circle of life, right? It's not going to live forever. When that lichen dies, more lichen will grow around it, right? Everything has a lifespan. And when that lichen dies, it adds organic material to that area. So we've got all of that dead detritus. that will then get broken down, and then we get more rock breakdown, then we get more organic matter, and we get more rock broken down, and then we get more organic matter, and this forms soil. From this process, this lichen's life cycle, we make soil from scratch. This takes a very, very, very long time. It takes way longer for primary succession to happen than secondary succession happens, mainly because primary succession requires us to form soil, and that takes a very long time. But after we've got a little bit of soil, we can get more grasses in there, and those grasses will live their lifespan, and they'll add certain things to the ecosystem, and then those will die, and then we'll get more organic matter, and then our soil will become more fertile, and so on and so on and so on and so on. So, the secondary succession, right? When a disturbance happens in a community, that community is not always completely wiped out. We can disturb a community without going straight down to bare rock. Secondary succession is after a lesser disturbance, something that's going to leave some stuff behind. It'll still wipe out a lot of the community, but it'll leave some important stuff. That important stuff, mainly soil. Secondary succession is a lot faster than primary succession because we have that source material. That soil allows things to grow a lot faster than it would if it was bare rock. So any new plants that make their way to this area, any surviving plants can thrive because they still have the soil in place. They've got no competition because there's nothing else around. So secondary succession still takes some time, right? It still takes some time to get from like a sapling to a bustling wooded area. But it takes way less time than if we had to make the soil from literally scratch. So this is secondary succession. With secondary succession, our key idea here is that we have soil to start with. We have soil to start with. Questions so far? Whew, sorry, excuse me. Goodness gracious. All right. So, primary succession, secondary succession. One has soil, one does not. Uh, so, secondary succession. It's we'll talk about more specific examples, but a forest fire is a great example of a disturbance that still leaves soil behind. So, here we've got our big disturbance. It does not leave bare rock behind. We've still got soil in place. Sometimes we even still have small plants in place. So we still have a pioneer species. There is still that first species to move in after a disturbance happens. It might be something like a grass or a small plant rather than lichen. But we still have that pioneer species. That pioneer species will allow for bigger species to come in. Those bigger species will add stuff like nutrients to the soil. Those nutrients in that soil allows for the bigger stuff, which allows us to get back to that original community or as close to that original community as possible. So that's secondary succession. As we can see here, this still takes like 150 years. Whereas with our, see if I can go back to our first one, have a timer. This one quite literally takes hundreds of years. So because that soil takes forever to break down. So this one can recover in like 150 years rather than 300, 400, 500 years. So when does secondary succession occur? We mentioned wildfires. This is also stuff like hurricanes, deforestation, and farming. So somewhere around here, a farmer just decides, hey, I think I'm done. Getting too old for this. I don't want to sell my land. I still want it to be mine, but I don't want to farm it anymore. Let's just let nature take it. So if this were the case, we would be left with that barren land, right? Just that soil and nothing else. Maybe a cover crop or two if we're lucky, right? Over time, we'll get some species move in, and then more, and then more, and then more. And eventually, it'll start to look very similar to the undisturbed ecosystems around that field. Hurricanes, deforestation, also big things, going to destroy a lot. But leave that soil behind. And these examples that I'm giving you aren't an exhaustive list. There are other disasters and disturbances that will lead to primary and secondary succession. But these are like the basics. So that is when secondary succession occurs. It is way, way, way more common than primary succession, at least nowadays. Post ice ages, it was mostly primary succession. So, why does succession occur? So, like I've mentioned, everything happens step by step by step by step. We can't move forward, we can't skip a step. This is because every organism changes the environment in which it lives. Every organism changes the environment in which it lives. There is something that any organism will take or contribute to the ecosystem in which it lives. Nothing is invisible. There is always an effect. So, when one species modifies an environment, say a nitrogen fixing bacteria moves into a soil, right, that allows more nitrogen to be in the soil. If we've got more nitrogen in the soil, it makes it way easier for the next species to come in and use those resources and grow and do its thing. And it might add something like iron to the soil, or it might create a more loosely packed soil as those roots spread out, or they might create more shade because they've got really long leaves, right? All of those things would allow a new species to thrive. If we got that shade, maybe one of our plant species needs indirect sunlight rather than direct sunlight. Plants can be picky like that. Marigolds. Marigolds are really, really good for soil. They release a lot of stuff. Uh, that's super great to like promote growth of other species around it. So if you're ever planting a garden, marigolds, as opposed to walnut trees. Walnut trees will kill everything around them. My high school English teacher used to tell us all to be marigolds, not walnut trees. I did not like that as a high schooler, so I'm not gonna make it. I'm not gonna say it here. But anyway, why does succession occur? Because one species will modify the environment and make it more suitable for the next. So, what is this all for? What's our end goal? Our end goal is this climax community. A climax community is a stable community that completes the succession process. That completes is in quotes because an ecosystem is never really done, right? It's not like, a cake that you put in the oven and then it's done when it's done, and you can overcook it or undercook it. An ecosystem will continually change. Uh, you don't have to write this second thing down, just the first. Because the second bit, is what scientists used to think. Because the way scientists think about these things changes all the time. So, we used to think that every climate had its own characteristic climax community. So, if it was cold, the climax community should look like this. If it was warm, the climax community should look like this. Rainy areas have a different climax community than a not rainy area. This is a very, 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 very simplified version of what actually goes on. There are so many other very, very small things that can contribute to what climax communities are possible. So that has kind of changed the way we look at ecosystems, at climax communities. So just another little show here, right here. This is our established climax community. That was our stable kind of stable. Where'd it go? Aha, community that is not in the succession process. Some sort of disturbance happens. We've removed all living things but the soil. We get our fast growing plants, and we finally reach that climax community again. But here's the thing, those climax communities aren't a stable thing. They are stable, but they're not unchanging. Just like us, right? We don't stop changing when our bodies stop growing, right? Communities, ecosystems are also ever changing. We have a bunch of individual species that will interact differently from one another. It's not predetermined. We can't look at an ecosystem after a wildfire, after a hurricane, and say, okay, in 150 years, we know exactly what this is going to look like. There is no guarantee that if a community is disturbed, it will return to its exact same conditions. If I were to burn down this wooded area over here, I'm not going to do that. But if something were to burn down this area out here in 150 years, if we were to walk out there, and if the students here in 150 years were to walk out there, they would look completely different. There is no guarantee that everything has the ability to return to that original state. What if that disturbance removed something that a species needs to live there, that ecosystem never gets back? If we are thinking about the farming example, right? If we've clear cut a wooded area and we've used it for agriculture for like years and years and years and years, that changes what the soil is made up of. We've added stuff to it. We've grown different stuff in it. The soil has changed on a very, very chemical level. So if nature were allowed to reclaim it, it might not be able to grow everything that it grew before. It might be able to grow different things. So we never know if it's going to be exactly the same. Questions so far? We're almost done. All right. So, humans do a lot of things. And we have the capacity to disturb these communities just as badly as a natural consequence, right? There are wildfires that humans start. There are wildfires that happen naturally. There are big disasters like hurricanes and tornadoes that'll ruin climax communities and send them into secondary succession. And there are things that we can do, like farming and deforestation. We can do major change to landscapes. And when we do that, we affect microclimates in soils, nutrient availability, acidity, alkalinity, uh, the microbiome, like all the bacteria that live in there. We, with these big changes, also affect the very, very small. And when we change the very, very small, it is really, really hard to get that back. The changes that these things have may or may not be reversible. Questions here? All right. So here is the thing. We've got a little bit more time than I expected to have, but that's all right. I think part of me thought it was Tuesday yesterday, so I kind of planned for a shorter amount of time, but that's all right. There is an exit ticket on Canvas for you to fill out. So if you could open up your Chromebooks, knock that out really quick. Remember, those exit tickets add up quickly. So please, 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 please do that now so you don't have to do it later. When you have finished with the exit ticket, I have left the little slips up on the wall. So if you did not finish what we did yesterday, you have the ability to do that. All right. Questions, comments, concerns? Alrighty.